Okay, let's go ahead and take a look at this warm up. 60 miles per hour is how many feet per second? Well, we would start a conversion chain with 60 miles. And one of our goals is to convert the miles into feet. So if miles is on the top, then it has to go on the bottom. And then we're trying to get it to feet. So what do you know about miles and feet? What's something we know about miles and feet? Correct. Every mile has 5,280 feet. Grant, pay attention. Okay, so now I'm done with that portion of the conversion chain because I've made it from miles to feet, which is what they wanted me to do. Okay, but now I'm not completely finished because I've got to convert 1 hour into seconds. So since hours is on the bottom, hours now goes up top, but I'm trying to get to seconds. So what do I know about hours? What's something you know about an hour? Right, 1 hour is the same thing as 60 minutes. And now that minutes is on the bottom, it goes in the top. And what's something you know about a minute? Right, 1 minute is 60 seconds. So now I'm finished with this portion of the conversion chain because I've made it to seconds. So I can cross out hours with hours, minutes with minutes. And now I multiply the numerators. 60 times 5,280 times 1 times 1 is 316,800. And then on the bottom, you just have 1 times 1 times 60 times 60, which is 3,600. And now you just divide those for your final answer. And what do you get? What'd y'all get? Nobody got it? 88 feet per second. It's the same thing as 60 miles per hour. Okay, now we are going to be working in your interactive notebooks today. So go ahead and get it out and turn it to page 24, and we're going to update the newest essential question that we'll be learning today. Okay, essential question 3. What are the parts of a radical? Okay, and then once you've updated that essential question, you can turn to page 26 where we'll be starting with that little flip book. Okay, does everybody have it updated now? Okay, now turn over to page 26, right here, and let me zoom in. Okay, and today we're going to be learning about the parts of a radical and how to simplify a radical. All right, parts of a radical. Okay, first of all, to have a radical, you have to have this radical symbol. Okay, so that's known as the radical symbol. Okay, now on the outside of a radical, and it would be smaller and up here to the top left, sometimes you may have a number, sometimes you may not. This number, whatever it is known as the index. Okay, so for like this one, we'll just say the index is 3, and so this would be a cube root. If there's no number visible, do you know what number is understood to be there? Right, a 2. Okay, and then that's called a square root. So if there's no number visible at all, it's an understood 2, and that's why it's called a square root. But if there's any other number visible, 3 makes it a cube root. If it were a 4 in the index place, it would be known as a fourth root, or 5 would be a fifth root, or so on. The number on the inside, we'll just call it, we'll put an 8 this time, is known as the radicand. Okay, so whatever's on the inside of the radical symbol is called the radicand. Okay, and all of these parts together make up what we call the radical. Okay, now like we were talking about a second ago, if the index is not written, like if there's nothing visible here, we know it's an understood 2, and that's automatically a square root. Okay, now flip open your paper, and we're going to just practice some of these, just identifying the index and the radicand. Can I erase? Yeah. Okay, so for this it says, for each radical determine the index and the radicand. So all you need to do is just put a little I for index and R for radicand. And for this problem, what is the index? Right, there's an understood 2 there. So this is a square root. And what is the radicand? 24, right? Okay, what about the next radical? What is its index? Right, so this is a fourth root, and what is its radicand? 128 into the 8. Every single thing up under is called the radicand. All right, what about the next one? What is its index? 3, so it's a cube root, and what is its radicand? Right, 16xy. Okay, the next one has an index of 6, so it's the sixth root, and what is its radicand? 448. X to the 7th, y to the 7th. Okay, and then the next one, what would its index be? Right, there's nothing visible, so it's an understood 2, so that's known as a square root. What is its radicand? 512. Okay, now you do the other 5 on your own. Okay, y'all finished doing those? For the first index, you should have put 2, then 3, then 3, 5, and 2. And then for the radicands, 512x squared, 1,000, negative 162, 125, and 98k. Okay, so everybody now understands the parts of a radical. Okay, now let's talk about simplifying radicals on the page to the right. Okay, square root of 4 is a pretty easy one. What's the square root of 4? 2. What about the square root of 81? Right? What about the square root of 64? 8. And what about the square root of 289? Okay, well, if you don't know, let's talk about how to type it in the calculator. Okay, see right here this button that says x squared? Does everybody see the button that says x squared where I'm hovering? But look what's above it in blue. See above it in blue is the little radical symbol? So to type in that radical symbol, what are you going to have to press first? Right, second, and then the x squared button will pull up the radical symbol. And now we type in the 289, hit enter, and you see that it's 17. Okay, now, these are all whole number answers because 4, 81, 64, and 289 are what we call perfect squares. The reason the square root of 4 equals 2 is because 2 times 2 is 4. Same thing for the square root of 81. Guys, don't go ahead. You're going to have to erase. The square root of 81 is 9 because 9 times 9 is 81. The square root of 64 is 8 because 8 times 8 is 64. And then the square root of 289 is 17 because 17 times 17 is 289. But is there a number that when multiplied by the same number will equal 48? No. Look what happens if I try to type in the square root of 48. Second x squared 48 equals that. Okay, so that is an answer, but for this unit, you're supposed to simplify them in radical form. For example, this is totally different. So say when you were in elementary school at some point and the teacher gave you something like this and told you to reduce it, didn't she mean you had to reduce it all the way down to 1/2? She didn't want you to write 0.5. She wanted you to reduce it as a fraction. Now, don't both of these still equal 0.5? So it's the exact same thing. They're equal to each other. This is just reduced form of that. That's all we're going to be doing today is reduced form of the radical. Okay? So let's look. The first thing you have to do when you calculate it and see that it's not a whole number, that this is not a perfect square, is you're going to do a factor tree. You're going to start by thinking of two numbers that multiply to make 48. What are some numbers that multiply to make 48? 6 times 8. Okay, then you continue in the same process. What are some numbers that multiply to make 6? Right, 3 times 2. What are some numbers that multiply to make 8? 4 times 2. And then out of these numbers, will any of them break down anymore? The 4 will break down into another set of 2's, correct? Okay, now, once you've broken all the numbers down to prime numbers, you drop them all down to the same level. Okay, so the 3 just dropped because it was prime, same thing with the 2, and same thing with that 2. Now, do you all know what I mean by prime number? A prime number is a number that can only be obtained by multiplying it and 1. Like to get 3, don't you just do 3 times 1? Same thing for 2, isn't it just 2 times 1? So those are prime numbers because the only way to get them is to multiply them by 1. Now, this is a little story that I tell for you to try to remember what to do, the procedure here. Okay, so this is a house, and the dad comes home, and he finds his twin daughters have invited their boyfriend over, and they're sitting on the couches with their boyfriend, holding hands, and that's not allowed, okay? So the dad gets very, very angry because his daughters have broken the rules, and he kills the boyfriend, okay? Because he's very angry. They're not allowed to hold hands in his house. And the 2 daughters get kicked out of the house, okay? So look, the 2 boyfriends have been killed. The 2 daughters have been kicked out of the house. This is the house. Little brother 3 was just in his room playing video games, so he was being good. He still gets to live at home. Whatever's on the outside of the house multiplies together and makes a 4 in this case. And so the final answer is 4 square roots of 3. Okay, now let me show you how you can use your calculator to check it. We already typed in the square root of 48 and we saw that it equaled 6.9. Now let's type in our answer, 4 square roots of 3. 4 square roots of 3 equals, look, the same thing. So we've done it right. We've just simplified this to simplified radical form. Kind of like a fraction, like I was talking about a while ago. I don't know where it went. Let's see. These are the exact same thing. They both equal 0.5. This is just reduced form. It's simplified. That's all we're doing here with radicals is these equal each other. This one's just simplified form. And we proved that by seeing that both of them equal 6.9. Okay, so now let's try another one. The very first thing you should do every time is type it in the calculator to see if it's a perfect square or not. So type in the square root of 72. And you see that it's not a perfect square because you get a decimal answer, which means we're going to have to simplify it by our new method, factor tree. So what are some numbers that multiply to make a 72? Any numbers that multiply to make 72? 8 and 9 will work. Okay, now 8 breaks down into what two numbers? 4 and 2. And 9 breaks down into what two numbers? 3 times 3. And then 4 will still break down one more time because 2 times 2. And then you bring down all of the leftover prime numbers so that everything's on the bottom level. That way it actually looks like a tree at the end. Okay, now that all of the bottom numbers are prime, which means that they can only be obtained by multiplying themselves times 1. You bring the dad home. He finds, this time will be fair, we'll say his sons have invited over their girlfriends. Okay, there's one of his sons and his girlfriend. Here's the other son and his girlfriend. He gets very angry that they invited them over, and he kills the girlfriend and kicks the sons out of the house. So 2 and 3 both get kicked out, and whatever gets kicked out multiplies together. And then little sister 2 was in her room playing with her dolls, and she still gets to live at home. And so the final answer is 6 square roots of 2. Now once you have your answer simplified, remember you've already typed in the original question to check it to see if it was a perfect square. Now we type in this one, 6 square roots of 2, to confirm that we did simplify it correctly. And we did. They're still equal. This one's just simplest form. Okay, so do you get what we're doing here? We're just simplifying radicals. Okay, so has everybody finished copying that work? Because I'm about to erase it before I try the next one. Everybody's got all that? Okay, square root of 220. The very first thing we do is we type in the actual square root of 220 just to make sure it's not a perfect square, because if it's a perfect square, you're done. You just write the answer and you move on. But if you get a decimal, that means you got to do a factor tree. Yes? It doesn't matter which number you mark off. Let me bring that word back up. Okay, you just, anytime you have a set of 2 of a number, like we had 2 2s here and 2 2s there, you circle sets of 2. Over here, you circle this set of 2s and that set of 3s. If there's 2 of them, you circle. And then it doesn't matter which one you kill and which one you kick out because they're the same number anyway. And then whatever's not circled goes back inside. So you're circling pairs, and then killing one, kicking the other one out, and anything not circled up in a pair goes back in. No, like you could actually, I'll try to show you in this one how they could actually not even be sitting side by side. So let me make myself some more scratch paper so that it's not messy looking. Okay, so when we do the square root of 220 on the calculator, we see that it's not a perfect square because we got a decimal value. So that means we're going to have to factor tree it. Now, 220 is a larger number. You may not be able to just in your head think of two numbers that multiply to 220, but use your common sense. 220 is an even number, so you know it's divisible by what? 2. So if you can't think of anything else, you could do 220 divided by 2, and that's 2 and 1/10. What else do you think 220 is divisible by? 11? Okay, 11 and 20 will work. And honestly, you have a smaller factor tree if you can start with bigger numbers like this. If you start with 2 and 1/10, your factor tree is going to go longer because of that 1/10. So the bigger the numbers you can think of, the shorter your factor tree will be. Okay, now 11 is prime, right? Because the only way to get an 11 is 11 times 1. But 20 is not, so I'm going to break it down. What are numbers that multiply to 20? Okay, 10 and 2, or 5 and 4 would have worked. 11's prime, so it just keeps dropping down with the rest of them. Now 2 is prime and 11's prime, so they're just going to drop down. But that 10 can break down one more time into a 5 and a 2. And hold on, I don't want to write them where it looks like a 52. Okay, now let me erase this because it's kind of distracting me. That belongs to the previous problem. Okay, so now on the bottom row we have an 11 which is prime, a 5 which is prime, and 2's which are prime. That means we have a pair. We have a pair of 2's, so we circle them. Those are the kids that are being bad because that's the only pair we have in this factor tree. Now, one gets killed, and the other one gets kicked out of the house. This is the house. This time you have 2 siblings at home that were being good. So they both go back inside together, and they multiply together to make a 55. Anything that get put on the outside together multiply together, and anything that gets put on the inside together multiplies together. And so that's the final answer, 2 square roots of 55. So, and I'll show you that it's true. 2 square roots of 55 is the same thing as the square root of 220. This is just simplest form. Okay, let's try this one. Has everybody finished copying the work from the previous one? All right, what's the very first thing I should do every time I'm working one of these? Right, put it in the calculator first, because you're going to have to at the end anyway if you want to check your work to make sure they match up. And by putting it in the calculator first, you at least are confirming that it's not a perfect square. Because if it's a perfect square, you're done. You just move on. Okay, it's not, so that means we've got to factor tree it. So, give me some numbers that multiply to 260. Right, 26 and 10. Those aren't the only 2 numbers. There are plenty of others. It doesn't matter if you start with 2 other numbers. In the end, you should all get the same answer. Okay, what are some numbers that multiply to 26? Okay, so I'm going to write it this way just to show him what I was telling him I'd show him in a minute. Okay, 10 would be a 5 and a 2, right? And then aren't all 4 of those numbers now prime? So now, this is what I was trying to explain a while ago. We still have a pair of 2's. They're just not sitting side by side. It's okay. We can just pretend like when the dad walked through the door, they heard him and got scared and quickly separated from each other. Like one of them ran to the other side of the couch. That way maybe they won't get in trouble. But the dad knows better. The rule is you don't invite over your boyfriend when he's not home. So he kills the boyfriend and kicks the daughter out of the house. Okay, so it's okay that they're not side by side. There's still 2 of them, so you circle them, kill one, kick one out. And then this time we had 2 kids being good, a 13 and a 5. And then they both get to go back inside, and they multiply together to become a 65. And then you can check it by typing in 2 square roots of 65 and seeing that it equals the exact same thing that the question did, so you know you have simplified it correctly. Does that make more sense? Okay, now we're going to do some more practice on your packets, or in your packets on page 19. So you can close up your interactive notebook and turn to page 19 in the packet. Okay, number 1 is a pretty easy one because everybody knows the square root of 64 is 8. But let me just show you why it's just an 8 and there's no longer a radical symbol. You don't have to write this down. I just want you to watch. Okay, everybody watching? Say that I don't know that the square root of 64 is 8, okay? And I start doing the factor tree to it. Numbers that multiply to 64, I'll just say, since I obviously don't know about 8 times 8, otherwise I would know it was 8, I'll just say that I know that 16 times 4 is 64. Remember, you don't have to write this down, you just need to watch. 16 breaks down into a 4 times 4. 4 breaks down into a 2 times 2. This 4 breaks down into a 2 times 2, and so does this one. And then these are just primes, so they just drop all the way to the bottom. Okay, so see how now when I go to circle all of those sets, I have a set of 2's here, a set of 2's here, and a set of 2's here. So that means every single thing got circled. So everything is either getting killed or kicked out. In which case they all multiply together to make 8, because 2 times 2 times 2 is 8. And since there was nothing being good, nothing was left uncircled, there's no need for a house. Nobody gets to live inside anymore. Out of the kids anyway. So do you see why the square root of 64 is just 8 and there's no longer a radical symbol? Because if you look at it this way, nobody was being good. Everybody either got killed or kicked out, so nobody's living inside anymore. Okay, so now let's look at number 2. The square root of 128. First, I type it in just to confirm that it is not a perfect square and to have it ready to check my answer in a minute. And I see that I get a decimal, 11.31. So that means I've got to factor tree it. What are some numbers that multiply to give you a 128? How about 4 and 32? You could have gone with 2 and 64, but like I said, I like to start a little bigger because that makes the factor tree end faster. So 4 and 32. 4 then breaks down into a 2 times 2. What will 32 break down into? 16 and 2, okay, or 8 and 4. Either one of those would work. This 2 is prime, so it just continues to drop. But this 16 breaks down into a 4 times 4, 8 times 2, and then this 2 is prime, so it just drops. Are we done with our factor tree? Not yet, because we still have numbers in it that are not prime, right? 4s are not prime. They'll break down once more to another set of 2s. And then don't forget to bring down all the prime 2s. That way everything's on the same level, and that way when you go to circling, you don't miss anything. That's a problem I see every year is kids get lazy about bringing them all down to the same level, and then they'll like miss things when they start circling. Okay, we have a set of 2s, another set of 2s, and another set of 2s. So the only thing that's still going to live in the house is this one that wasn't circled. Out of the 3 that were circled, one of each is going to be killed, and one of each is going to be kicked out, making what on the outside? What will go on the outside? Well, remember we multiply, so 8. 2 times 2 times 2 is 8. Yeah, you always multiply whatever's on the outside together and whatever's on the inside together. Okay, now we type in 8 squared to 2 just to verify that we did do everything right, and you see that we did. Okay, now let's look at number 3. Can I erase all this work? Nobody still copying? All right, number 3, the square root of 216. The first thing I need to do is type it in. And I see that it's not a perfect square, so I'm going to have to factor tree it. Okay, what are some numbers that multiply to give you 216? Okay, that'll work. 12 times 18. And then 12 will break down into, what numbers multiply to give you a 12? Okay. What numbers multiply to give you 18? Okay, what numbers multiply to give you 6? Right? And then this 2 is prime, so it just drops down. What numbers multiply to give you 9? Right? And then this 2 is prime, so it just drops down. Now that every single number on the bottom level is prime, we're ready to circle, kill, and kick out. So, we have a set of 2's here, and a set of 3's here. So on the inside, these 2 guys that didn't get circled get to go back in, and they multiply together to make a 6. Of the pairs, 1 gets killed in each pair, and 1 gets kicked out in each pair, putting what on the outside? 6 as well. Okay, and then we can check it by typing in 6 squared root of 6, just to make sure it matches up with the same decimal we got when we typed in the question, and it does. All right, number 4, the square root of 512. First thing we need to do is type it in to confirm that it's not a perfect square, or to just get ready to check the final answer. Okay, we are going to need to do a factor tree. So what are some numbers that multiply to make a 512? Anybody got anything yet? 16 and 13? Oh, 16 and 32. Okay, that'll work. 16 times 32. Okay, what are numbers that multiply to make 16? What are numbers that multiply to make 32? Right. Okay, what are numbers that multiply to make 8? 4 and 2. And then this 2 is prime, so it just drops. What are numbers that multiply to make this 4? 2 and 2. And then what are numbers that multiply to make 8? 4 and 2. We're still not done, though, because we've got this 4 and this 4 that'll still break down some more. And then you got to drop all the prime numbers down so that everything's on the same level. Okay, now, say you're working a big number like this and you get to the bottom and you're like, ooh, I don't know if I did it right. All you got to do is multiply all those together. Like if I do 2 times 2 times 2 times 2 times 2 times 2, because there's 6 2's on the left side, right? And then, gosh, some of my 2's look like these. How many total 2's are there down there? 1, 2, 3, 4, 5, 6, 7, 8, 9? 7, 8, 9. If you just multiply them all together, your calculator will say 512, and you'll know you did it correctly. Okay, so now I'm going to circle up any sets I have. I have a set of 2's here, a set of 2's here, a set of 2's here, and a set of 2's here. So is there a need for a house? Yes. Remember, we knew there was a need for a house the second we saw decimals. Okay, because that means it's not a perfect square. What's going in the house? Just this 1, 2 that didn't get circled. Now, out of all the ones we circled, we're killing one of each, and we're kicking out the others. That means 4 2's are getting kicked out. And what happens when you multiply 4 2's together? What do you get? 16. Okay, so now we can check it by typing in 16 square root of 2. And we see that we get the exact same thing we got when we typed in the question. All right, number 5. Square root of 72. The first thing that we need to do is type in square root of 72. And we see that it's not a perfect square, so we're going to need to factor tree. What are some numbers that multiply to make 72? Right. What are numbers that multiply to make 9? 3 and 3. What are numbers that multiply to make 8? Okay, 3's prime, so it just drops. Both of those do. 4 breaks down into another set of 2's, and then this 2 is prime, so it just drops. So now we circle any pairs that we have. We have a pair of 3's and a pair of 2's. The only thing that was not circled was this 2. That means he gets to go back inside. Out of the pairs, one gets killed, one gets kicked out. And so what do we now have on the outside? 6, because that 3 and 2 that got kicked out multiply together to make a 6. And then we type that in, 6 square roots of 2, and we see that we have done it correctly. All right, number 6. What do I need to do first? Put it in the calculator, so square root of 192. And we see that it's not a perfect square, so we've got to factor tree it. What are some numbers that multiply to make 192? I got 8 and 24. When you're not sure, you literally, if this is even, you just start dividing by even numbers until you get another whole number on your screen. Numbers that multiply to 8 are 4 and 2. Numbers to multiply to make 24 are, right? And then 4 will break down into another set of 2's. This 2 is prime. 6 will break down into a 2 and 3. And then this 4 will break down into a 2 and a 2. And so now they're all broken down to all prime numbers. So now we circle any sets, any pairs that we have. We have a pair of 2's here, a pair of 2's here, and a pair of 2's here. So what's going back inside the house? The 3, the only thing not circled. Of the sets, one of each gets killed, and one of each gets kicked out, and whatever's kicked out together multiplies together, making what on the outside? 8. And so then you type in 8 square roots of 3, and you see that it matches. So you've done it right. Okay, your homework tonight is 7 through 15, but just the odds. So look, 7, 9, 11, 13, 15. Just those 5 problems. I want you to practice this tonight. Make sure you show your work if it's not a perfect square, and none of those are perfect squares. So show your work on all of them.